Hello there. Welcome to the CompTIA Network Plus 2009 Certification CBT Nugget. My name is Michael Shannon, and on behalf of CBT Nuggets and myself, I want to welcome you and thank you for choosing CBT Nuggets as your training solution. You've made a very wise choice, not only in pursuing the Network Plus certification, but also in choosing CBT Nuggets. The CompTIA Network Plus certification is recognized internationally as validation of foundation-level IT technical knowledge. By the time you finish this Nugget series, you'll have the important skills and knowledge necessary to go out and maintain, troubleshoot, install, control, manage, and configure basic network infrastructure. You'll also be aware of a wide variety of networking technologies, basic design principles, and adherence to wiring standards and testing tools. Now, CompTIA came up with this certification by going out and doing an industry-wide job task analysis and global survey in the second quarter of 2008. And the results of this survey are what's used in weighing the domains. And that's the first thing we're going to look at here in this Introduction to Network Plus Nugget. We'll look at the different domains and we'll talk about the topics and the requirements and objectives of those domains. Then I'll give you some best practices, some tips on how to be as successful as possible at the Network Plus certification and as a network professional. And then we'll go ahead and jump right into the content. We'll define what a network is, give you a little bit of a history lesson, and then we'll look at the different network topologies that are out there. Well, I know you're excited to get started, and so am I. So let's go ahead and take a look at those Network Plus 2009 domains. There are 6 domains to the Network Plus 2009 certification exam. You've got network technologies, which makes up 20% of the questions you're going to see in the content. You've got network media and topologies, network devices at 17%, network management, network tools, and then finally, network security. Now, we're going to take these domains in order. So we're going to follow pretty closely with the way they've laid out these domains and objectives. Now, what we're going to look at, first of all, in the first domain, we'll look at common networking protocols, things like TCP and UDP, common applications that provide IP networking like FTP and THCP and DNS and many others. We'll look at voice over IP protocols and email protocols, as well as management protocols like Secure Shell and SNMP version 2 and 3. We'll identify commonly used TCP and UDP default ports, things like port 23 for Telnet or port 80 for HTTP. This will help us in troubleshooting and in security. We'll also identify addressing formats, OSI Layer 2 MAC addressing, IP version 4, and IP version 6. Also in Domain 1, we'll look at IP addressing technologies like subnetting, classful versus classless, and network address protocol and PAT. We'll identify common IP version 4 and IP version 6 routing protocols like OSPF, RIP version 2, ISIS, and EIGRP. We'll explain the purpose and properties of routing, as well as look at wireless technologies. In Domain 2, Network, Media, and Topologies, we'll categorize standard cable types and their properties, like Category 5, Category 5E, and Category 6. We'll explore common connector types like RJ45 and fiber. We'll revisit common physical network topologies, which I'm going to go ahead and talk about right off the bat in this particular introductory nugget. And then we'll differentiate and implement appropriate wiring standards, like straight-through cables and crossover cables, rollover cables, and loopback. We'll look at WAN technology like T1, frame relay, DSL, ATM, ISDN, and more. We'll categorize local area network technology types like Ethernet and many others. We'll also look at properties of LAN technology like CSMA CD, collisions, broadcast, speed, and distance. We'll explain common logical network topologies like peer-to-peer, client-server, VPN, and VLAN. And we'll look at components of wiring distribution. In our third domain, we'll look at network devices. We'll look at installing, configuring, and differentiating between common devices like hubs, bridges, routers, switches, and firewalls. We'll also look at specialized networking devices like a multi-layer switch, an intrusion prevention system sensor, proxy servers, things like that. We'll also look at advanced features of switches like power over Ethernet and spanning tree protocol, VLANs, and trunking. We'll look at implementing a basic wireless network. In Domain 4, we'll look at network management. We'll learn and memorize the ISO OSI model, 7 layers. We'll look at configuring management documentation like schematics, baselines, policies, and diagrams. We'll evaluate the network based on configuration management documentation and learn how to monitor our network to identify performance and connectivity issues. We'll look at things like network monitoring utilities, system logs, and event logs. We'll explain different methods and rationale for optimizing network performance. We'll look at things like quality of service, traffic shaping, high availability, and fault tolerance. And then we'll implement several network troubleshooting methodologies, as well as learn how to troubleshoot common connectivity issues in different scenarios. In Domain 5, we'll look at network tools. Given particular scenarios, we'll look for the proper command line interface tool to use for the task, like traceroute, ipconfig, ping, nslookup, and many others. We'll explore the purpose of network scanners, things like packet sniffers, port scanners, IDS software. We'll look at the appropriate hardware tools, like cable testers, protocol analyzers, and many more. And finally, in Domain 6, we'll look at network security. This will be like a miniature version of the CompTIA Security Plus certification. We'll look at the function of hardware and software security devices like firewalls and intrusion detection systems. We'll explain the common features of a firewall and the different types of firewall technology. You'll learn the methods of network access security, like access control lists, tunneling, encryption, and remote access. You'll learn methods of user authentication, like a public key infrastructure, AAA services using Radius or TACACS+, as well as CHAP, MS-CHAP, and EAP. We'll look at things that affect device security, like physical security, and unsecure protocols and applications. We'll also identify common security threats and ways to mitigate against those threats. Things like denial of service attacks, viruses, worms, and social engineering. Well, that just about does it. Those are the 6 domains of the Network Plus 2000 certification and exam. It's a lot of information, and we're going to cover all these topics in about 30 nuggets. So let's go ahead and dip our toe in the water and just kind of define what networking is and look at some topologies. Get our feet wet. All right, let's do it. Actually, before we get into the content, I want to go ahead and give you some best practices, some tips and techniques that you can use to optimize and maximize this CBT nugget for Network Plus 2009. First of all, I want to recommend that you actually go through this entire nugget series twice. I know that's a tall order, but the Network Plus exam is long and difficult. This is going to be a nugget series jam-packed with vital information. So what I might recommend to you is this. The first time you go through the nugget series, nugget by nugget, go ahead and outline each nugget. Maybe take some notes along the way, but outline all the information. If I mention a term that you don't understand, go ahead and look it up at Google, for example. And then, right before you take your exam, consider going through the entire nugget series again with your notes sitting there next to you and just scanning the entire series. That's your best bet for passing the exam. Also, make sure you know the terminology. At the very end of this series, I'm going to give you a list of acronyms, and you should really know how to define all of these acronyms, and there's a bunch of them. So you may have a little bit of homework to do. I also want to recommend that you get some hands-on experience, and I will give you a couple of websites that you can go to where you can get rack time for routers and switches pretty cheap, from about $2.50 to $5 an hour. And I'll also show you my personal rack that I have set up here and give you some of my tips and tricks for setting up your own home lab if you want to do that. If Network Plus is really your first step in a long journey towards some vendor-specific networking certification, then you'll definitely want to go ahead and think about getting some of your own equipment. Even if it's just simply a switch, maybe 3 routers up on eBay. We'll talk about that later on. Also, since you're learning so much in this Network Plus series, you might want to double dip or maximize your time and consider taking the ICND-1 and ICND-2 exams from Cisco to get that CCNA certification. CBT Nuggets also has Nuggets for ICND-1 and ICND-2, but you're going to learn so much information in this Network Plus that there'll be a lot of overlap. So you might want to take this opportunity, once you're in this mode of accumulating network knowledge, to maybe look at one of those vendor-specific certifications. And then I want to recommend to you that you take the exam sooner than later. Don't go through this Nugget series a couple of times and then wait months before you take your exam. Get in there and hit it while it's fresh. Well, those are my best practices. My other advice is to relax. Just enjoy the series, sit back, have some fun, make sure that you're mentally fresh, got a cup of coffee or whatever when you're sitting down at these Nugget series, and pull in as much information as you can. Take good notes, outline the series, and just have some fun. Alright, let's go ahead and take a look now at defining what a network is. Now, I don't want to insult your intelligence because I'm pretty sure that you know what a network is, but just in case you're starting from square one, the best way to describe a network is to think about one of the most popular types of networks that are out there today, and that is social networking. Things like Facebook and MySpace. When you consider that those portals allow you to share a wide variety of different information types, using a lot of different types of technology and media, you pretty much put your finger on what a network is. The goal of a network is to move beyond your local operating system, your local space, your local database, your local applications, to connect to other nodes, to other hosts, other devices and users with the goal of sharing information. And this sharing of information can be sharing things like data, sharing hardware. For example, you think about peer-to-peer file sharing. You're basically using your workstation here as a server out there on the internet, and you're sharing files on your hard drive. Or maybe you want to share a printer with other people. Maybe you want to share applications or web content. The list goes on and on. Now, we have different types of networks. We have networks that are based inside of a building or inside of a house or on one floor of an office building that we call a local area network. Then we may extend that local area network geographically to other parts of a campus or other parts of your metropolitan area, or maybe geographically across oceans to create what we call wide area networks. We've also got specific metropolitan area networks. We've got storage area networks that share databases and storage hardware facilities. We've even got PANs, personal area networks. That may be a couple of devices using infrared technology or Bluetooth technology at a Starbucks somewhere. So we have all different types of area networks or network areas. The goal is still the same: sharing information in all different forms using all different types. Now, along with the concept of network is connectivity, and there's various ways to connect these devices together, and we're going to explore those in great detail in this Network Plus Nugget series. But along with networking itself, networking has addressing schemes, addresses that devices use, addresses that people and applications use. You've got network architectures, network management. You've got operating systems that use networking software. We call these network operating systems, or NOSs, like Linux, Sun Solaris, Windows, Novell, Apple. The list goes on and on. So now that we understand what a network does and what its purpose is, let's look at some of the ways that we can actually connect these devices together. And that brings us to the concept of topologic or topology. So why am I choosing to talk about network topologies first when technically speaking it's kind of farther down the list in the Network Plus objectives? Well, I've already defined for you and you understand what a network is. Well, once we decide that we have to connect devices or nodes or hosts up to one another, the next logical step is how are we going to do it? Okay? What's kind of the basic design of these devices being connected to each other? So we want to talk about, and since I said it's the next logical step, let's talk about logical topologies. Logical topologies are really the first place to begin. It's a higher level view than the actual physical topology. For instance, a message that is sent from, let's say, Dallas, Texas to Phoenix, Arizona logically travels between Dallas and Phoenix, but the physical circuit could literally be from Dallas to Fort Worth to Albuquerque to El Paso to Phoenix. So that's the difference. We're going to look at several different logical topologies and their configurations. And by the way, I'm going to go ahead and use some of my fantastic drawing skills here, and you'll see very quickly I'm kidding, but to draw these out for you. The first logical topology is a bus topology. And a bus could simply be a cable that devices like workstations here tap into. The bus is going to terminate signals on both ends. The signals travel to all the stations on the bus topology. And again, a bus could actually be a cable, or it could actually be a bus could be inside of a device called a hub that we'll look at later. Now another type of topology is a ring topology. And a ring topology looks like a circle here. The signals travel in a circle from one station to another. In ring topologies, what you usually have with this transmission is something called a token. And a token is basically saying, look, I have control of the network right now. So as this device has the token, it has the ability to send information around this ring. Once it's done transmitting, it gives up the token, and the next device it has to transmit grabs the token, and now it sends information on the ring. The most common ring topology is actually called token ring, was invented by IBM. Another type of ring that's used also for high-speed data networks is FDDI. FDDI actually uses fiber. It uses a ring topology. Actually, it uses two rings, dual rings, so you have fault tolerance. If one of the rings goes down, you can go over and use this other ring, concentric ring. Another type of logical topology or logical way to connect devices together, and these are just nodes or hosts or servers or workstations or laptops, is called a mesh. In a mesh topology, signals can actually take a number of different redundant paths. So if I have to send information from this station to this station, I could send a signal over here and then to the station. I could send it directly to the station, or I could send it over here. This is a very fault-tolerant scenario in the sense that if one of the links or the lines goes down, I've got other redundant paths. This type of mesh topology is very important when all of the nodes need to communicate with all of the other nodes. For example, if you're using telephony or if you're using networking for your telephone service like voice over IP, for example, well, all these nodes have to be on the quote phone network. So a full mesh topology is very likely and necessary for voice over IP transmissions. Now those are logical topologies, but you can also have a physical topology. For example, I might have my network physically look like a star. For example, this is a star topology up here. My physical star topology looks like a star. I've got a central hub and then other spokes going out to these hosts, but I might be logically using a bus topology. For example, inside of this hub is basically a bus, and all of the devices are listening at the same time. The signal travels to all the stations on the network in the hub, but only one station can respond to the signal. Or it could be a physical star topology like this one with a hub and spoke, but be a logical ring in the sense that, let's say this device has the token, it's actually sending this in a circle, you see, but the hub or the ring management unit is actually managing this particular ring. So it operates logically like a ring where only one device at a time has the token and it passes it in a circle, but it looks physically and it's set up physically like a star topology. So as you can see here, once you define that a network is connecting devices together, there's really two layers to approach the design of connecting those devices. You can think about it logically, which is basically kind of how the information passes from one device to another. How those zeros and ones that computers use get transmitted. So it can be done logically in a bus or a ring or a mesh. But physically, a physical bus means these devices are actually physically connected to the media itself, and only one is talking at a time. And these signals are terminating on both sides of the bus. So it can be physically a bus, where they're tapping into the cable. Or it could be physically a star, like we see up here. A star is also called a hub and spoke. It's physically designed with the cabling as a star, but again, logically, it could be a bus if the bus itself is inside the hub, or it could be using some type of ring logical topology. Or it may be physically set up in a ring. It could be cables. An old IBM token ring network could actually have cables setting up the devices in a ring, or it could be set up physically as a mesh, where all of the devices have connectivity to all of the other devices. This is the layout of the cables, the workstations, and network components. Oh, don't forget, there's one other type of physical topology, and that is, dink dink, a wireless topology, which is these little laptops here, okay? A wireless topology, which is its own kind of animal when it comes to a physical topology. There's no wires involved, but we just have simply an area involved where these devices can communicate with this access point, which is really a hub using radio frequencies. We'll return to the concepts of network topologies, both logical and physical, later on in this Network Plus Nugget series. I wanted to go ahead and just kind of get our feet wet, giving you an idea of what this training's all about in this introductory nugget. What else did we look at? Well, we looked at the 6 Network Plus 2009 domains, talked about some of the topics that you'll see in those domains. I gave you my tips and tricks or best practices for being successful as a network engineer and technician, as well as passing the Network Plus exam. We also defined what a network is and got a cursory overview of logical and physical network topologies. I hope this CBT Nugget's been informative for you. I want to thank you for viewing. We'll see you in the next nugget.